which gives us a total of 7. So that's a base 10. 7 base 10 is equal to 7 base 16, right? Now this over here, that's just a 0. We can fill in zeros ahead of it as placeholders, which gives us a 0 base 10, which equals a 0 base 16, right? So, coming up with the hexadecimal representation, we can say it equals 0, this being first, 7, because this is second, 5, then we observe the radix point, point A, and that is the hexadecimal representation of this binary number, or this binary number that I copied over to the right side here. Now, changing a binary number, the same binary number, I'll copy it over again. So changing this number again to decimal is actually, it's a little bit more tricky because 10 is not a multiple of 2. So, or 10 is not a power of 2 is the problem. So, we kind of have to do this a little bit differently. We have to observe how the number system works. So we know that this is 2 to the negative 1 place, 2 to the negative 4 place, 2 to the negative 2 place, 2 to the negative 3 place. My columns are getting a little messed up here, so I'll show you. And then this is 2 to the negative 4 place, right? Make sure you know that's a 2 there. So, then we look on the other side of the decimal. Now we know this is 2 to the 0 place right there, 2 to the 1's place right there, 2 to the 2's place, 2 to the 3's place, 2 to the 4's place, 2 to the 5's place, and 2 to the 6th place, and then 2 to the 7th place. So, what we have to do here is we just have to multiply 1 times 2 to the power in which it's sitting in, and we'll be given a decimal representation of what the number actually is. So, because I can't remember all of these, I'm going to bring my calculator over here. Of course, this one is going to be 1/2. This is going to be a 1/4 place. This is going to be a 1/8 place, right? Because it's 2 to the negative 3. So we know that we only have 1's for the 1/2 place and 1 for the 1/8 place. So we know that on the other side of this decimal, we're going to have 5/8. So if we're going to find a decimal representation of that, we'll do 5 divided by 8, and then fraction to decimal conversion on the calculator. And that gives us 6.25 times 10 to the negative third. So 0.625 is our decimal conversion. So let's go ahead and do the other side here. So then we have 1 plus 1 times 2 to the 2, which is a 4, plus 2 to the 4th, which is 16, plus 2 to the 5th, which is 32, plus 2 to the 6th, which is 64. And then all these, since they're zeros, they're going to be 0, right? So let's go ahead and sum up all of these places, and we'll find out whatever's on the left hand of the radix point. So I'm going to use the calculator for this because calculus is different from arithmetic, and somehow I always get calculus right, but I get arithmetic completely wrong. So 64 plus 32 plus 16 plus 4 plus 1 equals 117. So 117 and 5/8 equals 117.625, and that is our base 10 equivalent to a binary number. Remember that if you have to do any conversions, it's usually going to be easier just to put it in binary first, then convert to whatever base you need to do. Binary is a very powerful number system, and it's helpful to always put it in binary first, especially when you're converting to octal or when you're converting to hexadecimal. So, I hope you guys understood that well enough. If you have any questions or if you need a little bit of extra tutoring, come and check out the IEEE room or iLab in Innovation Plaza in ECE 312, and one of us would be happy to help you out. Good luck and happy studying.